Hi, my name is Mike Forder. I'm the Corporate Level 3 for AltaVista Solutions, and this is part of a video training series. Today we're going to happen to be looking at ultrasonic testing, performing vertical linearity in accordance with American Welding Society, and the code is D1.1. So what we're going to do is walk through vertical linearity in accordance to American Welding Society D1.1. So here we have an ultrasonic unit. We have a transducer that's 2¼ megahertz, and we also have a DS block. So what we're going to do is we're going to be looking at the percentage of screen height of the signal. So right underneath my thumb, it indicates it's 80% full screen height, which is where this indication is. So we're going to take the transducer and we're going to slide it towards the long portion of the block until we decrease it by half. So in this case, we're going to go to 40% full screen height, also now indicated right where my thumb is at. And then we're going to increase the gain by 6 dB. When we increase the gain by 6 dB, we effectively double the signal strength. So this 40% screen height should go to 80. In this case, it goes to 80. And we're going to record that value, and we're going to walk through that step several times over a 60 dB range. So again, we're going to slide it towards the long portion of the block, lowering the indication strength, increase by 6 dB. In this case, I've got a little bit low on my indication, so I'm going to back up that step and just verify that that's the correct number. So in this case, I'm at 39% full screen height instead of 40. So I'm going to go back until I get 40% full screen height. Right about there. Then I'm going to do it again. And I'm at 79. So it's just a way to verify that you have the correct values. Increase the gain. This happens to be 81% full screen height. Happens to be 78. We've got a couple more steps. Chord 81. And then what I've done for ease of increasing the gain is I've just stepped the gain signal to automatically do 6 dB when I change it. So now that we've completed the vertical linearity, we're going to take the values that we've recorded previously and we're going to input it into the calibration form. AltaVista has determined to put this in an Excel spreadsheet, but the AWS D1.1 codebook also has a calibration form that you can fill out by hand. So you take the serial number from the ultrasonic unit, from the transducer, and from the block, and you input it in your form. And then what I'm going to do now is scroll down to the graph, and it's highlighted the different dB readings that we've recorded, and I'm going to put in the percentage of the scale that we recorded previously. So, and what's going to happen is as I input the values, after we get several values in there, it will start to input and calculate the dB difference. As you can see, it starts to do the dB error and the collective error. So and that's where it completes. And it's important to note here that what you do is you take the closest value to 0 and make that your starting point. So what I've done is I've highlighted this particular cell, and this collective error is our 0, or our starting point. And for the collective dB error, it will add these together as you go up, and as this is the starting point, it will add these cells together as it goes down. And what that does is it plots a graph on the next page. Now, AWSD 1.1 says that you have to be plus or minus 2 dB in your vertical linearity. So just a quick read of this chart tells us that we have a particular ultrasonic unit that is okay to use and we can put back into service. When we record that values, as we stated earlier, that's required to be done every 2 months. At this time, this completes the video training session on vertical linearity. Thanks, and have a great day.